Vinam, I'm here with yet another video. Characteristic properties of different blocks of elements. First, the S block elements. Group 1 and 2 elements together form the S block as the valence electron enter the S orbital. These are very reactive metals and they are electropositive in nature, that is, they lose electrons and become stable. These elements are found to be largest in size in their respective periods. These elements are having the outer electronic configuration as NS1 or 2. For alkali metals, it is found to be NS1, and for alkaline earth metals, it is NS2. These elements are highly reactive, and out of that, lithium, sodium, potassium are found to be very soft in nature. They react vigorously in the presence of air and forming oxides and hydroxides respectively. Coming to P block elements. Group 13 to 18 elements belong to P block as their valence electron enter the P orbital. This block includes a variety of elements starting from metals, metalloids and non-metals. Group 18 elements which are considered as inert in nature are also included in this group. The general electronic configuration of P block element is given as NS2 NP1 to 6. There are 6 groups in this block. Out of it, 11 of the elements are found to be in the gaseous state. Coming to D block elements. These are known as transition elements as they are the bridging elements between the typical metals found in S block and non-metals found in P block. They all show metallic property and exhibit color in their solutions. They are examples of very good catalysts. They exhibit variable valencies and are good conductors of heat and electricity. They even show magnetic behavior. They are malleable and ductile in nature, and the D block elements have the general electronic configuration as N-1 D1 to 10 NS1 or 2. Coming to F block elements. F block elements are otherwise known as inner transition elements. The 14 different elements lying in between lanthanum and hafnium in the group 3 and 4 in the 6th period are known as the lanthanides or lanthanoids, and the 14 different elements lying in between actinium and rutherfordium in between groups 3 and 4 in the 7th period are called actinides or actinoids. These together form what is called the F block elements. The first 14 elements after lanthanum resembles lanthanum in its properties, whereas the next 14 elements after actinium resembles actinium in its properties. The F block elements are called so as the F orbitals are being progressively filled up, and they are known as inner transition elements as they lie in between the transition elements. Out of the F block elements, actinides are radioactive in nature, but in lanthanides, except for promethium, all others are non-radioactive. F block elements also show variable oxidation state and form colored solutions. The general electronic configuration of F block is written as N-2 F1 to 14, N-1 D0 or 1 N. Now we shall see what is anomalous behavior. The first member of every group has a different behavior from the rest of the members. This behavior is known as anomalous behavior. Now the question is why it arises. This occurs due to small size, high electronegativity, high ionization enthalpy, large charge to radius ratio, and absence of d orbitals. In the case of group 15 and 16 elements, they also show an additional property to form multiple bonds like p-pi multiple bonds. Coming to the next property, that is diagonal relationship. The first member of some groups are showing similarity in properties with the second member of the subsequent group. This property is known as diagonal relationship. This occurs due to similarity in the charge to radius ratio, their electronegativities, and their atomic sizes.